right. So if you look at this question, it says which one of the following has more neutrons than electrons, more electrons than protons. So how should we start? What should be our first step?
Should we write all of their electron numbers?
Yeah, that would be our first instinct that all right, we should write all of them and that way we'll be able to figure it out. But here's the thing. If you notice, then this one is saying more electrons than protons, which clearly means you're looking for negative ions. Okay. So that means it is going to be A or B. It can't be the other one. And then you are looking for more neutrons than electrons. So look in the periodic table, the proton number of chlorine is 17. With electrons, it's 18. But neutrons is 20. And if you take this one, this is 9. Electrons are 9 plus 1, 10, or 8, 10. So clearly the answer is B. So you see that half of our job was done already by just looking at the option that they gave us. Okay, so let's do this one. Chlorine exists as 3 isotopes, Cl35 with their abundance of 75.5% and Cl37 with their abundance of that. Sorry. Phosphorus only has one isotope. The mass spectrum PCl3 has 4 lines at M ratio Z. What is M ratio Z? It's mass to charge ratio, 136. This means that the charge is 1 and mass is what they're adding up. Which one of these lines will have the smallest height? Again, the height of spectral lines. This is what they're talking about. The lines that you get when you run it. So this is your mass to charge ratio. And this is the percentage or abundance and all that. So they're saying that you will get 4 lines. Which one is least likely to occur? Obviously, the one in which you have phosphorus, there's only one option, phosphor 31. But with chlorine, the least likely option or the option with the lowest probability, that's the one in which you have all 3 chlorine as chlorine 37. Percentage पूछ रहा है उसकी किसकी सबसे ज़्यादा होगी. So the likelihood of getting chlorine 37 all 3 times is much, much less. So chlorine 37, 3 of them. Yep.
ये नहीं समझ आया, एक बार फिर से रिपीट कर दें ये.
Sure. So why do you get these lines? These numbers are basically the mass of whatever species you're checking. So they're saying it's 136, 138, 140, and 142. How come you're getting these numbers? So 136 you'll get. So you have PCl3. There is 4 atoms there, P, chlorine, chlorine, chlorine. The phosphorus one is always going to be 31. But chlorine can either be 35, or it can be 37. So which chlorine is least likely to occur? The 37 one is least likely to be in both of them. But taking all of them of 37 is the least probable one. You can still get 35, 35, 35, जो कि सबसे ज़्यादा जिसका होने का chance है. Or a combination of that, like पहला 35 और बाकी 2 37 हो, या एक 37 हो और 2 35 हो. इसके अलावा 4 ऑप्शन, ये 5 ऑप्शन आपकी टोटल 4 ऑप्शन आपकी कवर होगी. That phosphorus is always 31, but chlorine you can get a combination. You can get a combination of all 3 as 37, all 3 as 35, or 2 as 37 and 135, or 235 and 137. That's a combination in which you can get these. So the least likely one is this one. And when you add them up, what do you get? So that is 8 plus 14, 22, and then 2 carried, and that is 142. So 142 is the one that is least likely to occur. मतलब 37 क्लोरीन आने का चांस कम है और तीनों 37 आने का बहुत ही कम चांस है. So total mass for this one is going to be 142.
Sir,
Most likely it comes out.
If the
Yeah.
question was that which one of these lines will have the मतलब सबसे ज़्यादा height, so then we would take all of them as 35. Right?
Yep, that's the most likely one. Yeah, so it is all of them 35, which will simply be 136, the mass. Okay, so that's the one with the highest height, the most likelihood. Okay, this one's really easy. Try to do it. You'll need a calculator for this. Done?
Sir, is it B? But I don't think how I did it is correct.
Let me see. I'll have to solve it. Yeah, it should be B. So here's the thing. There are multiple ways of doing this, but what you have to remember is that if you look at the number line, this is the easiest way I've found for this. So on the number line, you have 121 here, and the other is 123. So let me divide this. So this is 122, and your average is coming out to be 121.75. Now look at the distances. how far is this from this and how far is this from this? So this is 0.75 and this is 1.25. Okay, that is how far they are. Now, think of it like a tug of war. There is one team here and there's one team here, and they're pulling on the MR. If they're 50-50, the pull, it'll be in the middle. But if this guy is pulling it more, then it will go towards that. And the ratios come from the ratio of the percentages. So if I take the percentages ratio, it's going to be 3:5. 3:5, right? So flip them. So this guy is pulling on it 5 times more, and this guy is pulling on it with 3 times. So that's the ratio of the percentages. 5:3. So just take that.
3:5 कैसे बनी?
देखो, the average was 121.75, which is 0.75 away from 121 and 1.25 away from the other value 123. तो इनकी रेशियो अगर मैं करता हूँ तो 3:5 बनती है. उसको flip करना होता है because it's closer to the one that is more in percentage. So 5:3. So 5 out of 8 कितने percent बनता है? 5 divided by 8. That is 62.5%. So that means this is 60% of the time. Just like if you remember from O levels, chlorine was 35 and 37, but the actual value was 35.5. Why? Because the ratio was 1 to 3, which means this was 3 times more likely and this was 1 times less. And this was present 75% of the time and this was 25% of the time. By the way, that value is really close to what we did in the last question. 75.5 and 24.5. So your AR is nothing but an average of these values that you have. Okay. Okay. This is a very fundamental question, although it's really easy, but it's important to have the clear concept. So tell me, what do you think?
Sir, is it A?
So they have the same chemical properties. Yes, that is true because chemical properties depend on electrons. They have same atomic number. Yeah, they're isotopes. So they are the same element. They have same physical properties. Not really. The physical properties change from one isotope to another. Slightly, not that much. Yeah.
Number is the same thing as proton number. Or no?
Atomic number is the same thing as a proton. Yep. Proton number. Yep. So here's another question for you. There is an element with its relative atomic mass being 24, and one isotope is X23, which is 80% of the time. What is the mass of the other isotope?
So is it going to be 24.25?
Nope, that's not the answer. And then, does anybody else have an answer?
Sir, can we do it with the formula, like, of
We
relative?
can, certainly, we can.
Sir,
So
but
first of all,
I tried doing it, but I was getting like a really weird answer. I don't think it's right. I got 2.
What's your answer?
That is
2.8.
Yeah.
Oh, you're close. छोटी सी गलती है.
Sir, is it 25.8?
No, it's not. So let's suppose we have the other one and I'm going to give it a value y. Chalo, theek hai. What is its percentage?
20.
20%, yeah. So your average is 24, which is 80 times 23 plus 20 times y whole over 100. So that gives me 2400 minus 80 times 23 divided by 20, which is going to be y. And that comes out to be, hold on, 28. There you go. So yours was 2.8. Maybe kind of division में 10 का offset आ गया था. So the value is 28. You can do it through number line as well. So, sorry. So if this was a number line and this is 23, which is, and this is 24, and this is y. So this is, the ratios are 4 and 1, which means if this is 1, this is 4. So what is 4 steps away from 24? 28. You can also make a graph of this, but obviously if they ask you, they will never do that. So the graph will come out to be, at 23, you will have a peak, and that peak will be for 80%. And at 28, you will have a peak, and that will be, sorry, that will be for 20%. And yeah, and that is how it goes. Can you calculate the relative the AR if the graph is this?
6.
What, 6?
0.6.
No. What are you doing?
I don't know.
Is it 318?
What are we
Come
supposed
on.
to do?
क्या करके रहे हो तुम लोग?
Or 636?
I got 63.6.
Yeah, that's close. I think that is the answer. I'm not sure.
Oh, okay.
So there is base.
63.6 is the answer.
Yeah,
So
it's
here's how you
40.
do it. So the ratios are, so the mass, the weightage is 63 times 7 plus 65 times 3 whole over the total, which is 10. So there you go. That's 63.6. Okay. Okay, which of these is correct?
There can only be one right answer.
I'm not sure. Multiple हो सकता है.
And then 1 and 2.
1 and 2
1
are
and
correct.
2.
Yeah, 1 and 2 are correct. Yes. So both of them are correct. Okay. We have bromine molecule and we run the peak for this. So bromine molecule is this. Okay, so we did it for bromine molecule. मुझे बताओ ये हर पीक किस वजह से आ रही है? Which atom is or which species is responsible for each of the peaks?
Wait, sir, what's the question?
So the question is that which species are responsible for each of these peaks? So definitely something is responsible for the peak at 79. Something else might be responsible for 81. So you कौन सी species हैं which are responsible for these peaks? Because we just had bromine molecules.
Sir, what do you mean by species?
Species is any particle that is responsible for this.
Like, I guess atoms are 79, 80.
Atoms, ions, radicals. What are we talking about? Yeah.
So the 79 and 81 wale are maybe, and then
They may be what?
wait, sir, I don't know.
So notice that 79 is exactly half of 158 and 81 is half of 162. And you have two atoms, which means one of them is bromine 79 and the other one is bromine 81. Of course, the peaks always come from charged particles, so it is Br positive one, and all of them are positively charged because this is M over Z, where Z is 1. Okay. Now, how do you get bromine molecule if you have Br81 and Br79 available? You have two options.
You can do
Which bromine are you
79,
going with?
79, or
Yeah,
79.
you can exactly. So 79 and 79, or 79 and 81, or 81 and 81. Judging by the height, which isotope is more likely to come?
79, 81.
Those are the only two isotopes available. What do you mean?
So like 79 plus 81 is the...
You're saying that's the most likely one?
Yeah,
that is true. That is true because you can either have the first one as 79 and the second as 81, or the first as 81 and second as 79, which increases the probability. But judging by the height over here, you can see that they're both 50% of each other. They're equal to each other in probability. So if you know that both of them are available 50% of the time, what is the AR of bromine?
80.
80, because it's exactly half. Both of them are of the same weightage. And that is why, and what are the probabilities now? Now this is 25%. This is also 25%, and this is 50% of the time. And that is how they're divided. Okay. Another question. Why is the mass or relative atomic mass of copper not a whole number?
Yeah, because the relative atomic mass takes into account the abundance as well.
Yeah, that's right.
Your whole number is the average of all the isotopes.
Yeah, you're right. Okay. Now, we used chlorine for this, Cl2 molecule for this. So what species are responsible for the peaks here? Notice that one is halfway between 30 and 40. So that must be chlorine 35 with plus. And this one must be chlorine 37.
So how do you know that it's always plus?
Because neutral particles will never give us any peak. The peak comes because you're able to bend them using a magnetic field. And you do that if you have. because we always use first ionization energy to make these. It can be -1, it can be -5 even, but by tradition we use +1. वो आसान होता है सबसे, उसमें सबसे कम एनर्जी लगती है. Okay, so what peak is responsible for 70? What species is responsible for the peak at 70?
Chlorine 35.
And chlorine 35.
Yeah, both of them in 35. Yeah. And as you can see, this is the most possible one or most probable one. Then the 35 and 72. Oh, sorry, 35 and 37. My bad. And that is present in 72. And then the 74 one, which is 37 and 37, which is the least probable one. Okay. So as you can see, the probability diminishes much faster because the peaks are like that. Now they're in the ratio 9, 6, and 1. Why is that? What does that mean? The peaks are in the ratio 9, 6, and 1. What does that mean?
Does it mean that like chlorine like 35 and 35 occurs 9 out of 16 times?
Yeah. It is 9 times more likely to be chlorine 35 and 35 compared to 37 and 35. Or 9 out of 16 times you get that. Yep, you're right. Okay, moving on. Draw the shape of the S orbital. What did you draw?
The sphere.
A sphere, yes. It should be a sphere. You can just keep a circle or you can also draw it like this. And what about P? Draw P. Any one P. So did you draw a double?
Yes, sir.
Okay. Draw D. You have two options in D. Either you draw a butterfly or you draw this weird shape. How many electrons are in D orbitals?
10.
10.
In
Oh,
D
yeah.
or-
Yeah. D. How many orbitals in a D orbital?
5.
2.
What do you mean?
An orbital can only accommodate up to 2 electrons.
Oh, I thought you said
No matter where it
Yes,
is.
sir.
So the idea of D orbital is just to confuse you.
Okay.
Okay, how many electrons in P subshell? 6. And how many electrons in third shell? P subshell. P has 3 orbitals, so 6.
Sir, what did
Okay.
you mean by this question?
Wait, sir, what's the question? I don't understand.
So what I'm saying is that you have P subshell. So here's the thing. You have shell and its capacity is 2n squared, where n squared is basically the number of shell and the orbitals that you have. Then you have subshell. Subshell can accommodate 2 times however many orbitals it has. So first can accommodate, S has just 1 orbital, P has 3 orbitals, D has 5 orbitals. So the electrons it can accommodate is 2 times that. And then how many electrons in an orbital? Pauli's exclusion principle tells us that orbital can only have up to 2 electrons. It can't have more than 2. Okay, so there you go. That is how you get it. So it doesn't matter where the orbital is. So it could be in D, it could be in F, it could be in S. It's going to have just up to 2. But the subshell matters. So if you have a bigger subshell like F, it will have 7 orbitals. So every orbital can have 2. So that is 7 times 2. And then shell is basically 2n squared. So if I'm talking about the third shell, it will be 2 into 9 squared. 2 into 9. Why? Because the total number of orbitals is second has 1 for S, 3 for P, so that is 4 orbitals. So total electrons उसकी वजह से हो गए 8 और फिर D, so that is 5 of D. Okay. Define the term first ionization energy. What is the meaning of the term first ionization energy? So I'll make it easier for you. I'll write the equation for that. So if I have an X atom, first ionization energy is when I convert it to this. So take that equation and write it in your own words. Tell me, how will you write it?
It's the energy required to remove 1 mole of electrons from 1 mole of gaseous atoms to make
Perfect.
1 mole of cations.
The cation idea is not important, but yeah, this is perfect. Okay. Write an equation for the third ionization energy of oxygen. Third ionization energy of oxygen. Again, you're talking about oxygen atom. So it should be O, should be gaseous, should have already lost 2 electrons. And then you convert it to remove the third one and an electron. So that's the third ionization energy of oxygen. Now here is the data for oxygen. The ionization energies. How does this give evidence of two shells being there? Tell me.
Because there's one big jump after the sixth ionization energy.
Good. So this big jump, this big change to high transition energy tells me that there are two levels. There's one level here and there is one level here. Okay. How does this show that oxygen is in sixth group?
Because there are 6 ionization energies before the jump.
Good. So there are 6 electrons in the large shell. That's what it shows. How does it show that there is an electron pair repulsion in oxygen or spin pair repulsion? Over here. And over here, you're changing the subshell. Why? Because if you look at oxygen, this, and then this. So when you remove this one, it's much easier. That is over here. But after that, after you're done with these three, you're removing this one. That's much harder. There's a big jump of 3000. Of course, it's not comparable to this jump, but still within the shell, there is a transition.
सर ये वाला कॉन्सेप्ट एक बार फिर से बता दें.
दोबारा देखो. So when you're removing electrons, you're supplying energy to do that, right? So look at the small jumps. There's one small jump here that it's almost 3 times the energy. उसके बाद वो उतनी बड़ी jump यहाँ पे आती है 3000 joules की, kilojoules की, sorry. And why is that? That is because if you look at the configuration, then this is the values. So when you're removing the very first one, you're removing this one, which is easier to remove. Why? Because you have spin pair repulsion. And then we're removing the fifth one. You've already removed this. And this one is particularly hard. There is a jump of 3000 kilojoules. Why? Because there is, again, some spin pair repulsion, but this is closer to the nucleus because it's in a smaller subshell. So when you remove this one, वो 10,000 वाली energy change यहाँ पर ये वाली तब आती है.
Sir, so can we say that it's harder to remove a paired electron?
It is easier to remove a paired electron.
Then
because
why
there's
is
spin
the
pair
energy
repulsion.
more?
Because you are jumping to a smaller subshell. That counter affects the spin pair repulsion. मतलब
Okay.
अगर आप सेम शेल में रहते हो स्पिन पेयर को करो ना तो वो आसान होता है because the repulsion is more and the shell isn't changing, so shielding is the same. But अगर आप एक शेल ही छोटे पे जा रहे हो तो it's going to be attracted more. तो वो जितनी मर्जी स्पिन पेयर रिपल्शन कर ले, the major impact is coming from the smaller subshell being closer to the nucleus, being more attracted, all of that. Okay, Allah Hafiz.